Have you ever wondered how your computer can juggle like a million things at once and not even break a sweat? Well, the secret is one of the most important ideas in all of modern software, multithreading. And today, we're going to break it all down. I mean, just think about what's happening on your screen this very second. You might be watching a video, maybe an ad is loading on the side, and you're scrolling through the page, all of it happening at the same time, without a single hiccup. It seriously feels like magic. So how on earth does one single application do all of that at once? Well, that magic has a name, multithreading. It's the engine that makes modern software feel so incredibly fast and responsive. It's the reason our apps can handle so many different jobs at the same time, giving us that seamless experience we all just expect now. Okay, so let's get right to it. What exactly is a thread? To really get multithreading, we've got to start with the most basic building block, the absolute smallest unit of work a computer can handle. A thread is basically the smallest possible sequence of instructions that your operating system can manage on its own. So think of it this way. If your entire web browser is one big process, then inside that process, you've got lots of little threads running around. One thread might be playing the video, another is busy loading images, and a third is just waiting for you to click your mouse. But here's the crucial part. They all share the same memory. And that is the secret to their power. This table really lays it all out, doesn't it? Just look at the rows for memory and communication. A process has its own separate private memory space. That makes it really isolated and safe, but it also makes it super expensive to create and really slow to communicate with. Threads, on the other hand, share their memory. They give up a little bit of that safety for just incredible speed and efficiency. That one difference is pretty much the whole reason multithreading is so powerful. So that comparison leads us right to a term you'll hear thrown around all the time. People always call threads lightweight processes. But what does that actually mean in practice? You guessed it, it all comes back to that shared memory. See, creating a brand new process means the operating system has to go find and set up a whole new isolated chunk of memory. That's a really slow and expensive operation. Threads, they just skip all that. They reuse the memory that the process already has, which makes creating them, switching between them, and getting rid of them insanely fast. That's the lightweight advantage. And get this, here's a fact that might actually surprise you. Multithreading isn't some fancy advanced feature you have to turn on. In a lot of modern environments, like Java for example, it's just the default. Even the simplest Hello World program actually has multiple threads running in the background, doing things like cleaning up memory. It's happening all the time, whether we realize it or not. Okay, so we know what threads are. Now for the fun part. What do they actually do for us? Why is this whole idea of concurrency so important for the software we use every single day? Oh, the benefits are just huge. For you, the user, it means the app is responsive. Any long-running task, like downloading a big file, gets pushed to a background thread, so your user interface never freezes up. For the computer itself, it means we're actually using our powerful multi-core CPUs to their full potential, instead of just letting them sit around doing nothing. And for developers, it means we can build massive systems, like web servers, that can handle thousands of users all at the same time. But here's the thing, you can't just sprinkle threads on every problem and hope for the best. You really have to understand the kind of work you're doing. A CPU-bound task, something like heavy-duty image processing, is all about raw processor speed. But an I/O-bound task, like downloading a file from the internet, spends most of its time just waiting. And this is where the strategy matters so much. For those waiting tasks, having more threads is fantastic, because while one is just sitting there waiting, another one can jump in and use the CPU. And once you know what to look for, you start seeing this pattern absolutely everywhere. Your browser uses threads to keep the user interface separate from all the network requests. The web server that browser's talking to, it's probably spinning up a new thread for every single user request. Even the code editor that a developer uses depends on background threads for stuff like spell checking, just so that the typing experience stays perfectly smooth. So multithreading sounds like a silver bullet, right? It seems perfect. But with any really powerful tool, there's always a catch. And the very thing that makes threads so efficient, that shared memory, is also the source of their biggest dangers. So yeah, while threads are lightweight, they're not exactly free. Switching between them still costs a little bit of time, and each one needs its own little piece of memory for its own stuff. But the real problem, the thing that gives developers headaches, is the complexity. Bugs in multi-threaded code are a total nightmare to find because they're random. They might only pop up when the threads execute in one very specific, very unlucky order. And this leads us to a really crucial point that seems completely backward at first.
adding more threads doesn't always make your app faster. If you go too far, the CPU starts spending more time just managing and switching between all the threads than it does doing any actual work. And that overhead can grind your whole system to a halt, making your app even slower than if you had just used one thread. So the biggest dangers all come from that shared memory. When you have multiple threads all trying to read and write to the same piece of data at the same time without any kind of coordination, you can run into two classic nightmare bugs.
First up is the infamous race condition. This happens when your final result depends entirely on which thread wins the race to get to the data first. Imagine two threads are both trying to increase a counter, let's say, count plus plus, at the exact same time. You'd expect the number to go up by 2, right? Well, not so fast. See, that simple little count plus plus operation isn't just one single action to the computer. It's actually 3 separate steps. Read the value, add 1 to it, and then write the new value back. So picture this. Thread A reads the value, which is 5. But before it can write 6 back, the system switches over to thread B, which also reads 5. Now eventually, both threads will write 6 back to memory. The counter only went up by 1 instead of 2. You've literally lost an update, and now your data is wrong. The second monster you have to watch out for is a deadlock. This is like a digital traffic jam where nobody moves. Imagine thread A has locked a file that thread B needs to use. At the same time, thread B has locked a database record that thread A needs. Neither one is going to give up what it has, so they both just wait forever, and your application just freezes solid. So, with all this incredible power and all this incredible danger, what's the big takeaway here? How are you supposed to use this tool without, getting burned? Well, it all comes down to one golden rule. And the golden rule is this: do not add multi-threading unless you actually need concurrency. It's that simple. If your task can be done in a simple, straight line, just keep it that way. You only bring in all the power and all the problems of multi-threading when you absolutely have to do multiple things at once, like keeping your app responsive while a big download happens in the background. At the end of the day, multi-threading is really a double-edged sword. It's the tool we have to use to boost performance and make our software feel modern and fast. But the very source of its power, that shared memory, is also its greatest risk, opening the door to a whole category of really tricky, unpredictable bugs. The real skill isn't just knowing how to use multithreading, but knowing when to use it. And with that in mind, what's something you do every day that you now realize is totally